Here, can you put this on the ground over there by all the other stuff? Hey, we are live. It's just on this camera right now.
Okay.
Hey, Taylor, when we do the interview, you just need to turn channel, is it channel 1?
What?
If you want to turn the floor mic down.
They're locked. I'm not using the mixer. The mixer's not in the mix anymore.
So when we want to take an interview, is it still going to have that behind it?
No. This mic goes with this camera, that mic goes with that camera.
Oh, so when we switch cameras, okay. Perfect. You won't have to do anything. Ben, come here.
Correct. So the mics are locked to the cameras. So switch one camera, you switch one mic.
All you're going to do is switch cameras. The remote camera's right here. Keith? Tell you when to switch. Right now it's on this one. They're also going to switch off. Demandless. So this is a remote cam, this is cam 1. I know, this is wireless. So that's the best quality.
Greatest part about that is that this just means that these are all the same
Yeah, I'll keep the one. Thank you.
Going on. So in order to have an equation, there is an equation out there for I use it when I'm going about testing. So I can't necessarily use an equation. But there's this relationship like this that as the equation increases, there has to be a high voltage as a voltage. So efficiency equation that is just that divided by I, which means that if I have a high voltage, low voltage, I should be able to going on. So this is great.
I mean, this is pretty nerd stuff. I'm not sure what word.
The control group was because it had the greatest rate, but also the second one stayed roughly the same. That worked in a much better fashion than I expected. It actually did better than but really on a compare I'm not necessarily sure that's so as far as I know this is possible. And then this goes on to the average efficiency. You can see here it was
Oh, we just started. So we don't even know. We haven't actually done it. But
say that the problem is we're not hearing.
Yes, say what?
And then the quantum dust themselves are not saying that's really as the reaction I know that it would change that didn't happen. So when I'm in my and it showed me it's just I don't know why and I couldn't
Oh, maybe.
They're actually covering half of it. You can't see anything.
Did you get everything?
No. This only has one outlet. I mean, you can put a triple tab. Yeah. Yeah, but this is. We said both. I didn't know how you meant.
What is the control soil far away from
Well, when we, you know what? So like, we'll just put a triple tap line here. So like football or soccer, you want to put the center.
That was listening to someone.
Because you want it to the camera in the center.
It'll take a while. Once we get
Make a hat. Yeah. Make a 3D print then you have this stick up, so it's like this can drop in, and this is on the top, and you can drop in. I think these are the internal light
We're getting it. We're getting it.
Where are you? I thought you have to be. You have to
ago, 3 a.m. and I was like, you know what? I don't like it. Delete, restart.
Which is where an acid solution, in my case, the hydrochloric acid, was added to chemicals and created that acid solution. My first time to test the acid solution, oh no, what is that?
So what the fuck?
I also actually really hard times which were just it's just awesome because
That's really awkward. It was like, against you.
Tell them that you don't have that.
Is it though? What is the vaccine? It's the same thing.
So all something that I did just do maybe very elaborate stuff.
And honestly, they keep
Finally, I can test my experiment where I design this, but I use, in the case of the chicken, for the soybean fat, I also need samples where, Celsius, and then I turned it. Once I completed all my wiregrass, so I was like, and I had to try to sell every single year. And what I'm looking for is
I know.
Good morning. Welcome to Positive Impact.
Are you on Jeremy? Are you on?
All right.
All right.
Good morning. Welcome to Positive Impact 2019. We got a bunch of science projects, and we're going to check out what is happening. Okay.
I'll be right back.
Yeah, I'll be right back. All right. That was a bad. Oh, did he switch? I think so. Reinhardt's up there.
Jeremy's the only one that knows.
I know.
Then you need to be on camera then.
Wait, I think Ben knows what he's doing.
Apparently not.
No, the other Ben.
Dawson?
Yeah.
He's never broadcasted. He's only done camera.
Yeah, but at least you're dressed for on camera.
No. He's like this.
this means that like the underlying was because
YouTube flags. No monetization for you. You should like kind of jacket. Yeah, exactly. So he wouldn't have room to I didn't even get
I also think that it could help make voices or guns from now on.
say nerve. Say nerve.
Further research in this topic would be to find a way to develop an
I know my God show. I know about it. They make brackets. No tax.
Only 300, no. It's that. Yeah.
They don't even give us questions. Like,
That local economy because of in their so this would be looking at what so currently it's that has been it hurts sometimes and they try to yeah, I'm not so they more research
Brenner, you didn't turn off comments in chat.
I had 5 comments I just
What?
I think I thought I
Jackson said people are chatting. Yeah, you shouldn't have that on.
drawing down my laptop.
No? Hey, language.
Watch your mouth. I don't have that key.
Hello, with me is Kuba, George, and Michael. Can you tell me what you got over here?
So basically here we have advertising but with the use of drones. As time as we progress forward, drones have becoming more and more popular with the use of different aspects of life. For example, in Australia recently they just started delivering by the use of drones, and now they're starting to experiment with it more and more. So we decided to try see what about advertising, because advertising with planes is, it can be very dangerous and it's also very costly. Drones are a lot safer, they are unmanned, cheaper, and overall more efficient in terms of what they can do.
All right, and when do you see this technology getting mainstream and in control?
I mean, it's already pretty mainstream. Like as George said, they're being used in various industries already. So the only question is, like, will people accept it as a new form of whatever concept they're implementing it?
And when do you see that happening?
Pretty quickly, I think probably next 5-10 years.
That is very interesting. Okay, thank you guys. Okay, and we're good. All right, we'll be back.
Mics are on. So when you're on this camera, when you're on the other.
Wait. All right, and we're back.
Hi, my name is Rowan Glussman, and I'm here to present my work on an analysis of adolescents' preferences in a political candidate based on that candidate's formality of speech, gender, and race.
All right, very interesting. Can you tell us a little bit more about your project?
Well, I don't have a lot of time now, but I can tell you the results, and the statistically significant results that I got were that my particular test population found female candidates to be statistically less trustworthy than male candidates and rated themselves more likely to vote for a black male candidate than a white male candidate.
All right, very interesting. Thank you, and good luck. All right, we're good. All right, and we're back. Can you please introduce yourself and your project?
Hey, my name is Sushi Butt, and I'm working on improving the minority carrier lifetime of cat-tail.
All right, very interesting. Can you go more in depth about what that is?
So cat-tail is currently the lowest cost solar cells that we have on the market. It's about 40 cents per watt, and we're continuing to just work on making that cost lower, so it's more affordable and more competitive against coal and oil and that kind of thing.
Okay, that's very interesting. All right, thank you. Thank you for your time. All right, good luck. All right, and we'll be back. Okay, and we're back. Can you please introduce yourself and your project?
Hi, I'm Alexia, and I'll be talking about fuel cells today. So, pretty much the synthesis and application of emerging materials in fuel cells.
All right, and what is that going to be used for, or what is it used for currently?
So, fuel cells are a really great source of backup energy. So, when there's big power outages, like the one we saw in Venezuela, fuel cells can help reboot the system.
All right, and do they have this technology now, or is this like a future thing, or like?
So fuel cells definitely are in usage right now, but they're not that widely implemented. So by improving the process of preparing that material for fuel cells, hopefully we'll have more of them used. So.
All right, that's very interesting. All right, thank you for your time.
Yeah,
good luck.
Thank you.
All right, and we're good, and we'll be back soon.
that I could and then I will test it using base characterization to see if it's in the right structure that I want. And the threshold for, well, the decision block is if it goes 95% across the place. That's the decision. If it is, then I push it. If not, actually keep the sequence. So design it, tinker with the different conditions until I finally. And so initially I started with a pretty simple synthesis process called solid state. It's only really doing. I start with oxide filtering, I add ethanol, and then I mix it really well using the evolved pressure. And lastly, I synthesize it by hydrogen. So that's why I use the X-ray diffraction. And essentially this passes X-ray that goes through a mirror, and as it passes through the crystal, it is diffracting, resulting in specific diffraction patterns. And looking at that data, I can understand what compounds and structures are present. So I looked at temperature and atmosphere of the furnace. That's where the photosynthesis happens. And the atmosphere I looked at was air by precipitation, 100%. So I think 5%. I'm implying that the 105 is not the actual gas. So, and for the temperature, so in literature they use 1200. I just wanted to see what 1000 would do, because having lower temperatures allows you to test temperature. So that would be nice, but that's not necessarily the focus is more atmosphere. So this is what the data we have from this experiment. And I have the stars indicating which aligning points are across my body. So as you can see, there's a lot of mathematics. There's a lot of theory. I did notice that increasing that temperature is good. So probably my data supported. Oh my gosh! And also it's better to use hydrogen in the air because that's what we're seeing that allows for the release to take place. Since there were all of the techniques, I decided to try this called cycling technique. And here I'm actually this is important because the nitrate I dissolve in citric acid, and instead of just
right, and we're back. May you please introduce yourself and your project?
Yes, I'm Jackson Gross. I'm a senior here at Wheeling High School, and my project is being able to use what's called a metal organic framework to actually harvest water from the air.
And would you be able to go into more as like what that process is?
Yeah, so what you have to do is after you synthesize the whole MOF as itself, you leave it out for about 17 hours out of an open box, and you allow the MOF to absorb the water from the air, and then you close it and you allow it to be heated. In the perfect world, it would be outside by the sun, so it doesn't use any electricity, but what I did is I just used a heat lamp and heated it for 7 hours. And you had to keep the outside of the box cold, so that way the inside would be even hotter, so that way we create more condensation and create more water.
And when you harvest the water, what are some of the uses that we can use for this harvested water?
Well, the water itself, after it's taken out of the box, is automatically drinkable. You don't have to filter it or anything and things of that nature. So this could be used for water shortages in countries that desperately need it, like places in Africa like Libya or Egypt or the Congo, and even other places around the world like Afghanistan and Mongolia and even Laos and Cambodia, where places that really desperately need water because less than 75% of that population has access to clean water. And even places like Flint, Michigan, it could work really well as they continue to try and solve their water crisis until they get their process fixed for now. So for that kind of thing, it's a temporary use, but for places where it's desperately needed, it could definitely be a permanent use.
And when do you think we could get this technology out and able for mainstream use?
It's already been out for a while. It has been out for mainstream use. It's still in development. Omar Yagi at Berkeley has actually been able to develop a new MOF made out of aluminum. The one I made is out of zirconium, which is much cheaper, which should help along that process. But he's already been doing trials in Arizona where the humidity is around 20%, and he's still getting good results in terms of how much water he's collecting. So it should, my own personal estimate, it's about 15 to 20 years before it gets out into the mainstream, possibly even sooner.
And according to your research and experiments, what kind of metal works best with this kind of technology?
Well, just to explain it a little bit more, it's just the base of it. It kind of looks like a gray dirt, essentially. So, but obviously, in terms of cost and results, I was only able to really work with zirconium. I wasn't able to work in any other different bases because of how long the process takes to synthesize. But I think overall, if I had the chance to use aluminum, I think aluminum would have worked better because just of cost and things of that nature.
All right. Well, thank you. Wish you the best of luck. All right. Thank you for spending your time with us.
No problem.
All right. We'll be back. All right, I'm back here with them. We have sound now. Would you guys be able to introduce yourself and your project?
I'm George.
I'm Kuba.
And I'm Michael.
All right, and would you be able to introduce your project?
Yes. Our project was on advertising with the use of drones and how it's going to benefit society. Basically, what we decided to do was figure if we look at advertising with the use of planes by banner towing, if we would be able to replicate that with drones and how that would help.
Okay, and how exactly would that help? Like, what do you like? How do you see this technology being used realistically?
It's a lot safer than actually using a plane for advertising by the fact that there's no actual pilot in that flying that aircraft. This is an unmanned vehicle. It's a lot smaller, a lot more efficient, a lot cheaper, and is also a lot easier to fly and operate than an actual plane.
Is there going to be any other uses for drones besides advertisements?
Yeah, currently there are a lot of other uses, and right now Amazon using them to deliver packages, and then in the medical field, it's actually being used in place of emergency services because drones can get to the patient faster than an actual vehicle on the road.
All right, and has there been any flaws with this kind of technology that we know of yet?
Currently, there are restrictions to flying drones, clearly, because a while ago there was a whole incident with flying drones near an airport, and now, currently at Wheeling High School, you can't fly the drones outside of the school because there's an airport within 5 miles of us. So you would need a FAA regulation and approval to fly that drone. So that is, if you're anywhere near a populated city or airport like O'Hare, you can't fly.
And I'm guessing that has, caused a bunch of setbacks with furthering this kind of technology. Yeah. Okay. All right. Well, thank you. That's enough. Thank you guys for your time. All right. Thank you. All right, and we'll be back.
Let me write that down first. So you're saying oxygen. I've never heard a judgment like that. So I watched
We've never had a judge like that.
very chemistry heavy. Oh my gosh. Okay. That's so wow. That's so
So understand.
okay, give me some context.
Okay? I don't want to blow you away.
Oh, you put in J under your and then I select, like, there's this program that helps me run understand that. So then there's a periodic table, you choose the elements you're looking for, and then you click get analysis, and everything needs to be updated.
Okay, so how did you determine the amount of
Oh, versus like other materials. Okay, so it gives me a list of undercosts. And so it's that I will upload a previous, I guess, thesis. So I think that's like, oh, I see.
and your instrument is going to be a little different.
Okay. See one that speaking from it wasn't just because I was saying that I could do it. And I emailed Advertisements. How come you did it so simply? got one coded. It's a lady who change that to white, which is really usually people would change that other way. Yeah. Change it to black. It was already black, and then when hydrogen, when I was testing it, after the test, it was a lot. That I've met like so many times. I see you, I'm like, I know her.
So with the electron, the electron has enough energy.
Like, I was so much BS. Like, no, I asked him.
Positive, negative.
He was like, oh, do you want to do LinkedIn? He retired, but like, you see materials. He's like, oh, I was actually used to say oxygen hopping and oxygen fighting. All my life. Like, PhD level. I still have one more to do. Like, okay. 16. Oh my gosh, these people kept me like a whole extra session and enough.
They're there for like
16, can you present to me really quick? I know you're probably like right now.
Which, if you look up, and if you add
I understand why you don't like it, but you didn't really. Yeah, like it's scary. We're getting through it. We're getting through this. It's fine. There's one.
Yeah.
Oh, you guys are cute.
This thing is really cool because it just wants to
You'll be right. So, yay. Pretty much, fuel cells are,
just because of the way you
energy, electricity, right? And
the color is
I don't know if you've heard of electrolysis. That's pretty much what this is. But in that process, you're switching chemical processes. And so, depending on the reactions there, that will change how well it is. So, I pretty much worked with the material structure of the material that I wanted to achieve. Because then it has solid, but it's not natural. That's why I had to pretty much play around with temperature and atmosphere. I used this fancy machine to determine if it was that structure. I did some chemical reactions to get the how to compare what data looks like. It's kind of weird, but pretty much that's what it is. So you see this pie chart that says 96%. So I don't know if you guys have done but the integral is 96% shows the area, like out of all the area under the curve, and now it's together. And you can literally see, it's getting better, right? From like salt and pepper to green to black, black is quality color, right? And then you get quality butter. Also, butter less for outages. So, I don't know if you guys heard about what happened in British money. So, they lost a lot of and what's happening is because this year I'm not working with myself, I'm working liquid battery dynamics and both in a different direction. I like those, but yeah. So once you did your spiel, can you Sorry, finish your group chat.
I'm nervous.
It's fine. It's fine.
In there? In there.
All right, and we're back. Would you guys be able to introduce yourself and your project?
Sure, my name's Jasmine.
And I'm Alex.
And for our positive impact presentation, we're evaluating the ability of ferrofluids to clean up oil spills.
All right, and how does that exactly work?
So I'll take that one. As my partner is very confident. Anyways, so the way it works is that right now we're trying to see ferrofluid, which is a magnetic property. When it interacts with oil, a neodymium magnet can actually suck up the ferrofluid with the oil, and this could be extremely beneficial in oil spills as it accounts for a greater recovery and it's more cost effective.
And the magnet you mentioned, what can you talk more about that?
Okay, I can take over from this one because I know this one. So we use the neodymium magnet. It's actually one of the strongest commercially available magnets online, and so we were able to use that as one of our main components for our experiment.
All right, so that's very interesting. But is this project, the technology for this project, is it mainstream yet, or is it still in development?
It's definitely not mainstream, just because, I mean, of course, there have been researchers that have looked into possibly using ferrofluid, but it's definitely not being used right now. The most common oil spoil cleanup techniques are chemical dispersements and booms and skimmers.
And just your estimate, when do you think it will become mainstream?
There's really right now, it's really in the research development process. So right now, maybe in a couple of years there'll be more information, but it's not going to go mainstream anytime soon.
We're just hoping that our experiment actually just brings to light that there are newer options available for cleaning up oil spills.
Well, that's very interesting. Thank you for your time. All right, good luck. All right, thank you. All right.
I thought they didn't read the page, and then this guy like showed up specifics on the opposite. Yeah, you're good. 612 presentation total 600.
Hey, you two. What's up? What up, you two?
Let me turn on the mic. We don't want to do that again.
He's already switched on.
Are we live?
Start. You already switched.
Okay, and we're back, I guess. All right, would you be able to introduce yourself and your project?
Hi, I'm Maximus Beach, and I'm from Oak Park and River Forest High School. I'm a junior, and I did my research on the manipulation of propagular pressure using the nematode C. elegans and T. aceti as a method of modeling biological invasion.
All right, and what can that be used for?
The model that I created using the two microorganisms could be applied to real-life examples of invasive species and native species, and that data could then be collected and given to government agencies like the EPA, and they could tighten regulations using the model and tighten regulations on those transportation methods, the ways in which these organisms are getting into areas that are not indigenous to.
Okay, that is very interesting. Is there any specific examples that you have of this technology, or is it still just like in the research phase?
So the specific example is what I actually did, and so as you can see here, I kept the amount of the native organism consistent throughout, but I changed the number of the invasive organism to see how that affected the end population of the native organism. And so from there, that model could be used in the future with other organisms.
All right, and just out of curiosity, how long did it take you to conduct this experiment?
It took me 3 or 4 months to do all my background research, and then it took me about a month to conduct my research.
Wow, that's very interesting. All right, thank you for your time. I wish you the best of luck. All right. All right. All right, and we're back. Would you be able to introduce yourself and your project?
Sure. My name is Rishi Ray, and I'm a sophomore at Barrington High School, and my project is titled The Effects of Bacillus thuringiensis and Lystinobacillus sphericus on Low-Density Polyethylene. Now, essentially what I looked at was the synergistic effect of two specific bacterium on biodegrading polyethylene and how that increased the rate more than the specific bacterium individually.
All right, and then what kind of experiments did you conduct for this project?
Sure, definitely. So essentially what I did was I took the two bacterial agars and I inoculated them into a broth of the bacteria. And so what I did was I took samples of low-density polyethylene and essentially placed them in samples of the bacterial broth, so the Bacillus thuringiensis, the Lystinobacillus sphericus, and a composite mixture of the two. And after 9 days, I removed them and disinfected them, and I looked at the mass change before and after the exposure to determine how much it degraded, the low-density polyethylene samples.
And what were some of the results? Like, did it degrade at all, or? You know?
Sure, definitely. So initially, I hypothesized that the composite would degrade the low-density polyethylene at a greater rate than the two bacteria individually, and the data did yield those results. In fact, it degraded statistically significantly more than the two bacteria individually, which was significant for the purpose of my research.
All right. Well, that's really interesting. Thank you for your time. I wish you the best of luck. All right.
Oh my god! So I was like, the kind of chaotic part, so we didn't so we had to if someone wants to ask about the project, it's
Okay, and we're back. Would you be able to introduce yourself and your project?
Yes, hello, I'm Daniel Kuzic. I'm a junior from Niles West, and my project is about building metal air batteries and reducing corrosion within them in order to improve performance and make them more powerful, basically.
What can these batteries be used for?
So obviously these batteries, well not obviously, but these batteries are meant to be more heavy duty, so they would definitely be implemented in things like electric cars because they can pack so much electrical charge into such a small space. They could really be a competitor to lithium-ion batteries that we normally use in industry today. They're also much cheaper, so that would reduce the price of electric vehicles as well. And there's also the much wider application of putting them in the renewable energy grid because of weather, wind, cloudy weather, things like that. Solar power and wind power are going to wildly fluctuate. And so because of that, we need massive battery banks in order to store energy from overproduction. And in order to make a cheap, effective solution and efficient solution to that, the best battery to use would be the metal air battery.
And I'm guessing it's more eco-friendly than lithium batteries?
Definitely. Lithium requires strip mining, which is very ecologically damaging, and it also doesn't use toxic chemicals like nickel or cadmium, which is what you would usually see in other alkaline or just normal Duracell batteries.
All right. And when do you see this technology becoming more mainstream to the public?
So there's still a lot of challenges facing zinc air batteries. That's the specific one that I'm working on. There's both figuring out reducing the corrosion within these batteries, as well as making sure that they can recharge efficiently and effectively so that they can be reused many times over. However, considering that they're so promising that they could be way cheaper and way more powerful than lithium ion, I fully expect this to see rolled out in the next 5, 10, maybe even 15 years.
And how would you go about recharging these zinc batteries, right? All right, how would you go about recharging them?
So you would recharge them the same way as you would for a lithium-ion battery. Simply plug it in and introduce an electrical current to create the reverse chemical reaction. But the way that the chemical reaction works in reverse, it doesn't like to be very neat and just redeposits the metal all over the inside of the battery. And so we need to figure out how to make that much more uniform and deposit only on one place where we want it.
And would there be a way to like charge these batteries like how I charge my phone, just like put into a wall, or is it like a special outlet and a special system we need to charge these batteries?
Yes, you'd definitely be able to recharge these like your normal cell phone, although I doubt that they'll be used in cell phones and other small consumer electronics. Like I said, they have more of a use in industrial, more heavy-duty applications.
Okay, well that's all the time we have. Thank you so much. Good luck. All right, and we'll.
Very nice to meet you. Best of luck. Yeah. Absolutely. Interesting thing. Yeah. Okay. What are you guys doing? Okay. Hi. Nice one.
Just give me a countdown now.
All right, and we're back. Would you guys be able to introduce yourself and your project?
My name is Emily Lucas.
And I'm Taylor Goot.
And we study the effect of hexanol exposure on Cavendish banana ripening post-harvest.
All right, and what is this experiment used for?
We're trying to develop a way to make sure bananas brown slower because, as we know, a lot of people throw out bananas when they get too brown because they rot really quickly. So we want to reduce food waste in that way by making sure they brown slower.
And how are you making sure the bananas brown slower?
Hexanol has been shown to reduce browning in a lot of other fruits like apples and blueberries and other like tropical fruits. So we figured if it was used in bananas, which spoil very quickly, it could be very beneficial.
And what exactly is hexanol?
It's a chemical. It's naturally produced by avocados and many other fruits and vegetables. But it can also be produced artificially in factories. And it breaks down very quickly.
Okay, well, thank you so much. I wish you good luck. All right, thank you for your time. All right, we're good. All right, and we're back. Would you be able to introduce yourself?
My name is Steve Bradley.
All right, and so there is some more presentations out there. We can't go out there due to limitations with our equipment, but would you be able to talk about what projects and stuff out there you found most interesting?
Well, I'm going to talk more about the projects that I'm familiar with because I have been a volunteer at Wheeling High School in the Nanomaterials Labs. So I've worked with some of the students here with respect to their projects. One of the projects that's out in the hallway there happens to be a trying to remove fluorine from Chinese tea. And this was really a very interesting project because they had to make the material, which is a metal organic framework, and they used a synthesis recipe from a group at University of California, Berkeley that was published in 2014. But we didn't have the equipment here to be able to do it, so we had to modify that. But they were able to actually make a material that was what they wanted to make. It was actually smaller crystallite size than what the guys at Berkeley did, which is better for what they were trying to do. And then they had to use that to remove fluorine from Chinese tea. And one of the issues that came up was how do you measure fluorine? So they were able to buy a fluorine meter, but what you do is that you have to calibrate the fluorine meter. And to be able to do that, you have to have some water and a fluorine pellet, which they had. But as most of you probably don't realize, is that there's fluorine in city water. And so what I had them do was first measure, even though it wasn't calibrated, how much fluorine was in city water. And they went, oh. And so then they had to use deionized water. So this, or DI water. So this is the type of thing that, as a volunteer, I get to help the students address problems or try and overcome certain issues that they have, because these are projects that are not, they don't have a recipe to begin with. It's not like you have in chemistry or physics class. These are experiments that they have to design, and they never work exactly as you originally have thought it was going to work.
And would you say this was a good experience helping out with the student?
I'm having a ball. I'm retired, and I'm having a ball, and I really wanted to spend time on the technical side of things, and so I'm having a ball doing this and helping here at Wheeling.
All right, well, that's great to hear. Thank you so much for your time. Okay. Well, welcome back. All right, this is going to conclude our morning services, or our morning portion of the live stream program. All right, we're going to cut off for a bit, and we're going to return in an hour where we're going to show the final 3 finalists, and we might do some exclusive interviews with them later. All right, stay tuned. We'll be back in an hour, so we hope to see you then. All right, thank you. This is Jeremy signing off.